On October 3rd, as interstellar comet 3I/Atlas made its closest approach to Mars, the third of its kind ever detected in our solar system, all official NASA updates abruptly stopped. This isn't just a random occurrence. 3I/Atlas was discovered just weeks ago and immediately stunned astronomers with its oversized coma, wild brightness spikes, and plasma activity no one can yet explain. At the very moment scientists most need answers, the public channels go dark, fueling questions and a race to understand whether we're witnessing the most extraordinary natural event or the start of something far stranger. Why would NASA go silent now, and what's really happening in Mars's shadow? Comet 3I/Atlas, cataloged after a routine sweep by the Atlas Survey in Chile on July 1, 2025, immediately stood out. Survey telescopes scan the sky every night, but the odds of catching an interstellar object are vanishingly small. Before this, only 2 such visitors had ever been confirmed: ʻOumuamua in 2017 and Borisov in 2019. Both rewrote the textbooks, ʻOumuamua with its strange, elongated shape and unexplainable acceleration, Borisov with its unmistakable cometary tail and hyperbolic path. But those were isolated cases years apart, each a once-in-a-generation surprise. The discovery of 3I/Atlas was different from the start. Its orbit could not be traced back to any known solar system family. The trajectory, calculated within hours of the first detection, was steeply hyperbolic, meaning it came from outside the solar system, just like its predecessors. But this time, the numbers pointed to something even more unusual. Not just a flyby, but a near-perfect alignment with Mars, set to occur on October 3rd. The comet would pass only about 28 million kilometers from the red planet, close enough for every Mars orbiter and rover to try for a glimpse. The find electrified both professional and amateur astronomers. Automated alert systems flagged the object's rapid motion against the background stars, and within days, teams across the globe were submitting new observations. The Atlas team's initial report, posted to the Minor Planet Center, set off a scramble to book time on the largest telescopes. Astronomers ran quick simulations to project its path, watching as the predicted close approach to Mars lined up almost perfectly with the planet's current position. That kind of cosmic coincidence is hard to overstate. For context, the search for interstellar objects is a numbers game. There are about 1,000 active survey telescopes worldwide, and most nights bring nothing but routine asteroids and comets. ʻOumuamua was found by Pan-STARRS, Borisov by Gennady Borisov's homemade telescope in Crimea. Each time, the discovery relied on a mix of automation, luck, and sharp-eyed follow-up. In 2025, Atlas's automated system caught a faint, fast-moving speck just after midnight, flagged it for human review, and within hours, astronomers confirmed the interstellar trajectory. The announcement arrived with a sense of déjà vu, and a growing sense that something new was about to unfold. With the Mars encounter looming, the scientific community prepared for a rare opportunity. Telescopes on Earth and in space adjusted their schedules. Mission teams at NASA, ESA, and elsewhere began planning coordinated observations, hoping to catch every detail as 3I/Atlas swept past Mars. The stage was set for a close encounter that would push both technology and theory to the limit. Within days of the first detection, 3I/Atlas was already defying expectations. Early telescope images posted to public astronomy forums showed a coma that seemed to balloon in size almost overnight. By July 6th, amateur astronomers were comparing their stacked exposures and noticing that the comet's envelope had doubled in apparent diameter in less than 72 hours, far faster than typical solar system comets at similar distances. Some observers in Australia measured the coma at nearly 100,000 kilometers across by mid-July, while others in Europe reported even larger values, sparking debates about calibration and atmospheric seeing. But the real surprise came when side-by-side images from different observatories started circulating online. In one set, the comet's tail pointed away from the sun as expected. In another, taken just hours later from a different longitude, the tail appeared to split, with one branch veering off at a sharp angle. Threads on Reddit and the Cloudy Nights forum filled with annotated screenshots and speculation. Was this an artifact of image processing, or was the tail genuinely shifting direction? Some argued for camera quirks or local weather, but others pointed out that the effect persisted across multiple instruments and locations. By late July, a handful of well-known comet trackers were calling it the most inconsistent tail I've ever seen. As the object drew closer to Mars, the rate of reported anomalies only increased. A user from Japan uploaded a time-lapse showing the coma's outer edge pulsing in brightness, almost as if it were breathing. Another amateur, using a backyard spectrograph, claimed to see faint emission lines that didn't match any known solar system comet. The data was raw and unvetted, but the online community pounced on every new post, dissecting the details and demanding more. Twitter threads speculated about outgassing jets, magnetic field interactions, or even alien engineering, though most serious voices urged caution until more data could be confirmed. With so many conflicting reports, the story of 3I/Atlas was quickly escaping the bounds of traditional science. The object's behavior was being shaped not just by physics, but by a global swarm of observers, each armed with a telescope, a laptop, and a hunger for answers. The result was a growing sense of uncertainty and a mounting pressure to find a physical explanation for what everyone was seeing. Solar activity in late September brought a new layer of complexity to the 3I/Atlas story. On September 25th, a coronal mass ejection, or CME, erupted from the Sun, sending a wave of charged particles sweeping across the inner solar system. While official solar weather models haven't confirmed a direct hit, the timing alone was enough to get instrument scientists watching closely. Interstellar objects like 3I/Atlas, already rare, become even more interesting when they interact with solar plasma. When a CME crosses paths with a comet, it can strip away gas and dust, trigger sudden brightening, or even distort the tail. Effects that have been seen before, but never with an object from beyond our solar system. This is where Mars comes into play. The planet is surrounded by a fleet of orbiters and rovers, each carrying instruments designed to catch subtle changes in the atmosphere and sky. MAVEN, for example, can measure ultraviolet emissions and plasma densities, tracking how solar particles interact with the Martian upper atmosphere. If 3I/Atlas passed through a cloud of solar plasma near Mars, MAVEN's sensors might pick up a spike in ions or a flash of aurora. Mars Express and the EXO-Mars Trace Gas Orbiter have their own spectrometers, able to scan for unusual gases or light signatures as the comet approaches. Even Perseverance, sitting on the surface, could catch brightening in the sky with its Mastcam Z. Every asset has a different vantage point and a unique set of tools. The hope among scientists is that, by combining data from orbit and ground, they can piece together not just the comet's behavior, but how it interacts with the solar wind and Martian environment. For now, the data is still being gathered and analyzed, but the potential for new discoveries is higher than ever. An interstellar visitor, a solar eruption, and a planet bristling with sensors, this is the kind of alignment that only comes once in a generation. NASA's public websites and social media feeds went quiet at midnight on October 1st, right as funding lapsed and the agency entered official shutdown procedures. Automatic banners replaced mission updates, and most outreach staff were furloughed. The timing could not have been more fraught. On October 3rd, 3I/Atlas swept past Mars, with a fleet of orbiters and rovers positioned to capture every possible detail. Yet, with communications teams on hold, even routine status bulletins evaporated. For most missions, core science operations continued, protected by exception rules, but the flow of raw images, quick-look data, and public commentary slowed to a trickle. Outside NASA, the European Space Agency, and other international partners tried to fill the gap, but the absence of NASA's usual transparency fueled a storm of speculation. Some argued the silence was a simple byproduct of bureaucracy, a government shutdown's predictable effect on public engagement. Others, especially online, spun the blackout into something more, a sign that NASA was withholding dramatic findings or scrambling to interpret unexpected data. October's calendar only added to the tension. After the Mars flyby, 3I/Atlas would reach Superior Conjunction on October 21st, passing behind the Sun as seen from Earth, cutting off direct observation and radio contact. By October 29th, the comet would reach perihelion, its closest approach to the Sun, a period when comets often behave most unpredictably. The clock was ticking. Every day without updates pushed the story further from science and deeper into rumor. Mainstream researchers urged patience, reminding the public that careful analysis takes time, especially with limited staff and challenging geometry. But the silence, coinciding with a once-in-a-generation event, left the world watching and waiting. On October 3, 2025, 3I/Atlas became only the third confirmed interstellar object to pass near Mars, just 28 million kilometers away. Unlike its predecessors, ʻOumuamua and Borisov, Atlas drew attention for its oversized coma and sudden, unexplained brightness spikes. Archival records show that NASA reduced public communications beginning October 1st, coinciding with a U.S. government funding lapse, as confirmed in official statements. While some Mars probes, like MAVEN, had a unique vantage point to observe the event, no real-time data releases have been logged to date. To this day, the physical causes behind Atlas's plasma activity and conflicting tail directions remain unverified in peer-reviewed literature. Scientists agree that even without extraordinary findings, the observations from this period will shape our understanding of interstellar visitors for years to come. As of now, the full story of what happened near Mars and what NASA's instruments recorded remains incomplete, awaiting further analysis and disclosure.